This video is brought to you by ArchiTech Network and our online platform of courses where you can learn from world-class architects working in some of the practices that you can see in these videos. You can learn Grasshopper, Revit, Rhino Inside, Twinmotion, and some of our new courses on AI, and lots more courses that we're delivering over the next year. So please, if you like this video, check out our courses in the link below so we can keep bringing you more content like this. What's up, guys, and welcome back to the ArchiTech Network. Today, we're back with another one of our ArchiTech tours. We're going to be touring Mamou-Mani architects and also FabPub. Mamou-Mani are doing some really amazing work, and they also have a sister company, FabPub, where they actually 3D print stuff, laser cut stuff, and anyone can go and fabricate things. We're going to be talking with Arthur and Mathias from Mamou-Mani and FabPub. So without any further ado, let's go and check it out. All right, guys, so we're here with Mathias from Mamou-Mani and FabPub, and he's going to show us around a little bit. It's a super exciting space. Let's go have a look.
Thank you. Well, very welcome. We are here in our lovely rooftop office. We share, yes, as you said, I'm part of two companies, Mamou-Mani and FabPub, and the team here is also shared across the two companies. We work together very closely, and it's very nice to be sort of physically close together. We have a little workshop which is sort of just down there,
which we'll go and see in a minute.
We're going to go later, where all the fabrication happens. So we are sort of really trying to take things all the way from the drawing to the final physical object.
Amazing. Let's have a look at some of the
we have a lot of nice 3D printed objects around different scales. So we have small desktop printers, medium-sized printers, and we have a really large robotic system that's sort of really for architectural scale.
Coffee table.
Yes, this is from the Mandala. This is the product range we just launched online. So
people can go and buy this today.
People can go and buy this today. Yes, have a look around.
Cool.
It's a small but growing range, and I think we had our first sale yesterday, so we're off.
Awesome.
Yes.
And what is it printed out of? It's like a bio-based material, right?
Yes. I spend about 20% of my time just looking at materials. It's a big part of what we do. We are trying to have biodegradable, compostable materials. And I think the material is about a third of the product, so it's a big component. And because we really want to make a difference, it's really important that we are on top of that. We know what's in the product, and we know we can work with it effectively, because most companies, most manufacturers are not legally responsible for what happens to their products once they reach their end of life, as it's called. And I think this is where we sort of step in, and we're trying to basically close this loop again, so to bring it back. And I think the reality is that if you are the manufacturer, you should really know what went into the project, and you're in the best position to bring it back into the circle. So this is the intention. We have a take-back scheme. If you, for whatever reason, you don't want that product or object anymore, we will take it back and we will put it back in our circular process. So this is the premise, both for the products, but also for all the sort of bespoke and architectural commissions we work on. So I think it's about 20 people in Mamou-Mani, about 15 people in FabPub. We have also members of the team who work across both companies. I think obviously the Mamou-Mani side does a lot of architectural design, but we also do a lot of the technical design that then goes into fabrication. So it's really taking things to a level of detail where you can effectively make things, effectively cost things, engineer them, to be able to sort of deliver it as a complete package. Mamou-Mani is famous for a lot of parametric design, and it's a big part of our process. I think the parametric tools are also very handy in using computation to create all the detail that you need in fabrication. I think 3D printing is unique in the sense that there is no cost disadvantage from having lots of different parts, lots of different designs. So, but that obviously, it creates an overhead on the design side, because you need to have a specification for all these different parts. If you have 1,000 different prints, you need to have 3,000 different 3D models. So you need to generate them, you need to test them, you need to engineer them, you need to cost them. So that it's sort of keeping this balance and sort of making sure that using software to make sure that there's not a sort of a big overhead created on the design side, where somebody has to draw manually 1,000 different versions or something like that. Here's our beautiful soundproof meeting room, and over here this is the main office. Beautiful rows of desks lit with skylights and views of London. And in the back there we have this is our library. We have some beautiful little prototypes here on the shelves. A lot of these things.
Products. This was your Burning Man project, right?
This was the latest Burning Man project. That's right. I think there's 3 on top of each other actually. Yeah. So this is the skyscraper version, I think, of the future skyscraper version of the one made. Yeah. So this is I think this is how it was built. Yeah. And I think it's sort of
it's like an amphitheater, right, where people do different performances.
That's right. It's sort of a performance sort of theatrical space, and then it sort of creates these walkways up here, these balconies up here that are exposed, sort of. You can kind of move around. I think people in Burning Man like to climb, so they also ended up on the roof and all across. So,
did you go? Were you able to go?
No, I wasn't part of this one. So I'm actually not super well positioned to talk about this in a lot of detail.
Super. Can I hold it? Super beautiful. It's always I really like the stuff you guys do is so geometric, and also like incredible patterns.
Yes, I think there is a lot of ways. With digital fabrication, I think there's a lot of really nice possibilities to do very detailed geometric detail, other detail that sort of also these sort of more organic surfaces that are just very difficult to manufacture using conventional means. Especially when there's a lot of variability in the design. So I think that's probably sort of there's also a flow of information coming from the fabrication side back into the design office, where there's sort of certain ideas or ways of working, where basically when you're sort of designing for manufacturing or you're doing sort of fabrication aware design, that there's some particular constraints and opportunities that come out of a process, and then that gets sort of built into a computational design tool. So you can really there's this sort of shape space, you could call it, and then there's a tool to really sort of explore that, but still stay within what the technology can achieve. There's some sort of more prototypes down here. So these are smaller scale prototypes that are intended then to be. So this is a prototype for a 1 by 1 meter square tile, and this is sort of going through the different printers. I can show you the actual 1 by 1 later in the workshop. So if it doesn't work on this scale, don't try it on the big one. Through back there, so with the products, for example, we have our stock. So this is currently our fulfillment center as well, and our little photo studio. The products route is very exciting for us, because a lot of companies doing products, it's very difficult for them to do prototypes of new designs, and I think this is kind of where we're trying to move in, that which has become also the standard mode of operation nowadays, where everything is online, that you make 2 or 3 samples, you post some good pictures online, and you see what the response is, and if the response is good, you actually go into production. So we're trying to sort of really use this opportunity, this sort of unique position that we have, by sort of also exploiting these ideas, these possibilities. Yes, and this is where
we got a really nice breakout space. This is where we have
space. Yeah, we have our monthly meetings, our lunch parties, all of those. Exactly. Yeah. So this is great. This is mainly it. Office injury, classic office injury. Yes. So this is currently our fulfillment center with our product. So I think we really We had have a look. And this is sort of a small planter range, the sort of entry level, more affordable range, and then the stuff that we are really excited about is the sort of bigger pieces. This is a really beautiful stool. And there's the same design in so this is in clear PLA. This is a wood PLA. So we call this is called wood. This is called brick, and this is a pearlescent finish. So this is the.
That's got a really amazing finish to it.
Sheen to it, yeah. So this is clearly the same design, same process, different material. So I think the material is a big part of this. We are producing our own material for these products, so that we can, we know what goes in there. Yes, and this is another nice product I really like. It's a funny one. It's not really it doesn't really have a full purpose. It's sort of like a beautiful decorative object that you can use in a number of ways. We have one that has a light integrated into it. It's a really nice wall piece, but you can also have it in a window. You can I'm quite excited to see how people use this. The idea is kind of a
very nice against
really
the light.
How to where will people put it? Sort of an open-ended
decorative thing. Really nice.
So this was started before. This project was started actually before I joined, but I think it's in Bali, and it's basically recycling a wood from a bridge. So the brief was to sort of look at all the components of the bridge, sort of take it, sort of virtually take it apart, and then sort of try to reconstruct them into this tower. And this is kind of in construction right now over there. So it's nice to see it happening. And I guess it's working in a circular way can take many forms. I think it's basically just sort of observing these material flows and economies and trying to fit the project into it, and not just sort of pick stuff from a catalog, but sort of try to use the material and what's available, or what as sort of another constraint in the process. I think it's sort of that's. I think particularly with these beautiful, powerful design tools, I think it's really nice to have some kind of constraints that sort of guide the project, so you can sort of find a niche and way into it.
All right, so we've just come across the road from your sister company Mamou-Mani to the Fab Pub, where the magic happens and things are printed, and Mathias is going to show us around.
Absolutely, welcome. Come in. Here we are. This is Fab Pub. This is our fabrication space, prototyping space, assembly space. So we have a large number of printers here. We have some more containers in the back with a small print farm and laser cutters. This is sort of, as I said, for more of the bigger stuff, there's a really large robotic system in the robotic 3D printer in the back, which we're going to have a look at. And here sort of a lot of samples that get done in the process using the 3D printed bioplastic. Also, there's some clay and stoneware terracotta samples here.
As this Arthur's, I think he was talking about his first ever printer.
This is Arthur's first ever printer. Yes, exactly. This is what started this many years ago.
That does look like a DIY printer.
When there was a lot less readily available products on the market.
Yeah. I've got one myself that's maybe not quite as raw as that, but putting it together, you do realize 3D printers are not that crazy complicated. It's like an X, a Y, and a Z, and a print head.
Yes, absolutely. I think the sort of card, the CAM origins are from the 1950s. I think the first sort of a lot of the G code that these printers use is the original MIT G code, based on the original MIT G code from the 1950s. Wow. And it's basically just the sort of movement in space. So you use stepper motors that can accurately sort of control their movement, and you have one or two for each direction, and you go around. And to be honest, the robots are similar. They just have a slightly different logic where they sort of mimic more the sort of process of an arm. So it's called a robotic arm. And the nice thing about the robot is that you gain a bit more freedom of movement. So on the robot, so with most of the printers here, we basically sort of print sort of from a flat base sort of up, going more or less straight up. With the robot, you can sort of introduce another sort of movement into it, and or sort of different. You can follow more complex geometry, which is really nice. I think with the ceramics, we are also incorporating more traditional techniques now. So this is 3D printed, but we are doing a series production at the moment where we start off with a 3D print, we create a mold, and then we do the slip casting on the mold, just to sort of increase the numbers.
That's very beautiful.
So there's still some defects on this, but this is sort of heading in the right direction.
The defects are kind of nice. They give it a bit of character.
Yes, so I think this is an interesting question and an interesting sort of tension, I think, because I think a lot of people expect things that are made by machines to have this certain level of perfection, but here, for example, the how wet the clay is has a huge impact on how well this print goes. Right. And if something's a bit too wet or a bit too dry, it gets some sort of detail appearing that is not part of the drawing, but it can become part of the aesthetic. I think for me personally, it's about having enough control over it so that it looks intentional. I think sometimes, sometimes we produce pieces. If you look at this, I don't know any one of us knows what happened here. This has some very interesting quality. It certainly wasn't what was in the drawing. So I think
it looks cool.
But it looks cool. This is technically clearly a fail, but it has stayed around because of its sort of intricate quality. And this is sort of pushing the machines a little bit to the edge. You can explore these things, and it's quite amazing how the technique. I mean, 3D printing, for me is quite similar to laying bricks. You're putting just things on top of each other, and with bricklaying sometimes it's quite difficult to sort of produce an overhang or like an arch or like a cantilever. So this is sort of what we are spending our time with. But it's sort of remarkable when you see how the material can recover from almost being sort of in midair, and then sort of generating these interesting things. This is of the 1 square meter architectural panel. I quite like this approach. I call it 2.5D printing because you're technically printing a flat part, sort of relatively low on the bed. And you could probably machine this kind of design like subtractively, but it would be much more costly because you would have to start with a thick slab. You would generate a lot of waste. So it's a really interesting way to use the technology to produce something that is essentially still a flat, sort of thin flat part, but you can do it sort of much more quickly and material efficiently.
Very nice.
This is sort of a medium scale printer. I think things sort of slightly increase as we go to the back. These machines are called delta printers because they use a sort of particular geometrical calculation to move, to create movement in space by using 3 towers with 3 independent motors that can basically position and lower an arm. So it's a quite sort of a nice way to create movement in space. That is actually so you use a lot less motors in this setup, But you can see that you gain a lot of height because in order to create the sort of mechanism of it, you need some head space. So this printer is about 3 meters tall, but it can only print to 1 meter. So it's sort of a...
It's like an elevator. It needs to...
Yes, you lose less hardware, but it requires a little bit more space.
Is there a reason why you guys favor the WASPs over other printers? Is the WASP printers the only one that you can scale up, for example?
I think WASP is a really good entry-level machine. They're kind of affordable for what they are. They don't scale beyond, so this is their biggest machine here.
Yeah.
So which is sort of 1 by 1 meter space, 1 by 1 meter build volume. So I think for the proper architectural scale, it's quite difficult to avoid robotic systems because if you can imagine if this printer would be 2 by 2 by 2 meter, you would need to have a 6 meter warehouse, which is sort of, and then it becomes sort of
a certain point
counterproductive. Yeah. So there's sort of different sweet spots for different type of technologies. And I think in the print farm we use a lot of Prusa's and Crealities, which are sort of the go-to machines for desktops at the moment, which are really quite well tested and continuously maintained and developed. So you have a big community of people out there also to help identify the issues. It's admittedly, it takes a lot of work to keep these things running and happy. It's sort of a lot of moving parts, and they definitely need some TLC. And like for the robotic system, for example, it's generally a rule that you have about 1 person per robot. It's quite difficult. I mean,
I didn't see the robot back there actually.
Yes, so
let's go.
we can
go and check it out.
Walk further back. Yeah, so here this is some of our ceramics production at the moment. So some of these pieces were printed originally and then turned into molds, and now this is actually they are slip cast to get to the sort of quantities. I think it's also sort of trying to work with at being able to offer things at different cost points. I think 3D printing is a little bit on the slow and expensive side. So if you can't fit these kind of budgets, we try to sort of offer alternatives, and the slip casting is a really nice, very traditional ceramics technique that we can combine with our other digital tools to create a solution that is more affordable than a fully 3D printed option.
Very nice. Then you got your big. This one's printing a table.
So this is sort of our product powerhouse. This is the tall WASP Delta Tower, and it's basically this is where these most of our mandala range comes from.
Amazing. And anyone can come and use these printers or hire them out, or?
So with the laser cutters, we actually have a public DIY service. The laser cutters are relatively simple to use and understand. With the 3D printers, we generally offer a bit of a service with the support, because it's if you've never 3D printed before, it's quite easy to make a lot of beginners' mistakes that I think are just sad and costly, and I think it's something where we try to, if someone comes to us with a request, we try to advise them. We say this is a good idea, this is a bad idea, we can offer sort of different sizes depending on the budgets, and we sort of help them. We are thinking about also offering the smaller print farm as a DIY, but this is still ongoing. We're doing some tests at the moment to see how well that works. I think, as I said, if you've done it before, you're probably fine, but if you've done it before, you probably have access to a printer already. So there's I think the laser cutters are more difficult machines to have at home, because obviously the laser burns away material, which produces fumes, so you need to have proper ventilation, and it's something that to do at home, it becomes a little bit too serious in terms of an operation, I think, to have the proper ventilation.
Cool. I've never seen printers this big. And then you got your your big guy.
Yes. This is the big guy, so it's quite large. It was really configured to cover proper architectural panels.
Yeah.
So we have a bed here that's 4 meter by 2.5 meter, and we can print right up to the ceiling here to 2.7 meters. So it's a sort of roughly the size of a car. You could print a sort of whole car body in one piece.
Have you got a name for the printer yet? Is she or he? I can see there is a name.
I think Arthur calls her it's Her Majesty to Arthur.
Majesty?
So yeah,
Very
Very
British.
Yes.
Her Majesty the Queen.
Yes.
Printer, I like it.
I'm not a royalist myself, but I think yes.
I'm Arthur Mamou-Mani. I'm the founder and the director of Mamou-Mani Architects and FabPub.
Arthur, thank you for having us and giving us a tour. I'm blown away by the space that you have and all these cool models and things and 3D prints. It's really cool to see. We'll talk a little bit more about Mamou-Mani and FabPub later on, I think. But I think, obviously, this is the ArchiTech network. We want to talk about the technology.
Yeah.
And I think technology plays a huge role in your practice, right? So maybe talk us through, like, what is the role of the technology side in Mamou-Mani?
Yeah. So I really started as a teacher. I was teaching technology, really, teaching Grasshopper, parametric tools on the weekend, you know, after hours. And I think what the parametric design tools did was that we switched from this notion of a creator, you know, with a piece of paper and forming forms, let's say, to an approach where we were developing systems, you know, in the form of algorithms, in the form of recipes, of parameters that could change. And so it completely changed, I think, the mindset around how architecture can be approached, or design in general. It's not even architecture, because I was teaching at Cadbury or McLaren Racing. It wasn't about architecture. In fact, I think parametric design completely opened up professions and completely broke this notion of industrial designers will do this, car designers will do this. Suddenly, everyone was confronted with a set of algorithms that were shared openly as well on Food for Rhino and stuff like that. So it was a really joyful, open, sharing spirit of algorithms. And that completely changed our notion of the isolated, I remember, I don't know, Zoom tour in the mountain of Switzerland, coming up with almost, you know, spiritual, sacred items. And suddenly, no, it was about sharing our knowledge. And I think this was this completely changed everything, I think, at least for me.
Yeah. No, you can see it's like it's a big part of what you guys do, and I think you have a really nice balance between the digital side, but also the making process. Obviously, you can see in the backgrounds. Maybe also talk a bit about the relationship between computation and where fabrication came into it and how they play into one another.
So when I quit my job, I bought a printer. At the time, there were these open source printers, the RepRap. You'll probably see it at FabPub. I still kept it. It's like this sort of open source hardware that you assemble. I think generally because I thought, well, not only can you design the systems, but you can let other people vary these parameters. So it's very democratic. But you can also realize it locally on your desk.
Yeah.
And so there was a convergence between this opening of tech that is empowering for everyone, because you could then package it into parametric files that other people could play with, whether it's clients or the general public. Yeah. And so very quickly I'm like, well, that's probably the biggest potential, which is empowering the public with design, because you are creating algorithms for design. So this notion of FabPub came very fast because that was it. Fabrication could be available for the public and could be locally made on demand with no stocks. It just seemed, well, isn't that applicable for any things we buy, really. So I got very excited by this very early on, and then moved in a pub, which only reinforced the names. I was squatting that pub for a little while, not far from here, and it just sort of made sense. The architecture studio sort of developed in parallel because people were asking for freelancing on Grasshopper, and I just kept on applying the teaching, and then it sort of developed a language, which became a portfolio, which became an identity.
Yeah, and that's how those two businesses rose.
Yeah, and it's always been yin-yang. Like, I always thought it was nice to have a company that's open to everyone else. I know that if an architect owns their technology, and it might just reclose everything and therefore not be the empowering force that I thought it could be. So by keeping, let's say, the portfolio, the signature, in one place that has an artistic dimension to it, and then on the other hand develop technology and materials and innovative material to have a real impact on society, and scale that up independently from me to some extent. I thought this would be a nice combo.
So give the audience a bit of a broad overview. What are the tools and technologies you use? Like, what do you design in? Are you using BIM in any way at this point? Give us a broad overview.
So we had a bit of an evolution. Obviously, at first was Grasshopper. That's what that's the world I come from. Originally I came from the generative component space. Remember MicroStation? This is what I learned at the AA at the time, when we had these amazing people around us, like Achim Menges or Neri Oxman. That was the sort of golden age of this early parametric tools. And so then I started teaching Grasshopper, and then slowly realized that Grasshopper needed its own plugins, and so we developed Silkworm for 3D printing, because it was just very hard to then use let's say a middle software for fabrication. So, and G-code is such a beautiful, simple, text-based, so we thought, okay, that should be an easy one to bridge. But then came, slightly larger industrial scale, construction scale, interiors, like for Orange. So we started working with Dassault System and Katia and sheet metal assembly to unfold metal sheets and stuff like that, which we're still kind of looking into. And they developed XGen, which is a plugin for Katia. And then came the big buildings, like what we're doing with the helium balloon at the moment. We're doing a big factory for helium balloons in France. And for that, we needed BIM, we needed Revit, then Rhino inside Revit, and all the tools around BIM, the collaborative cloud and stuff like that to identify clashes together. And then came the robots, and obviously robotics is a lot more complex than 3-axis 3D printing, so AI build came through. And so we slowly, I'll pass on all the Adobes and the Dropbox. But maybe on an interesting level in terms of maybe less designy but more organizationally in our office, because my wife is from tech, and so she brought a lot of the tech organizational project management. So we have Notion. Notion is a sort of internal wiki. We have Asana, timekeeping. We have EverHour. We have Slack. We have all these tools that allow to project manage and create the infrastructure between people. Rather than just design tools. It's equally important.
I think the Notion thing is a great one. I think every firm I've seen is making wikis with Notion.
To share knowledge.
Maybe one follow-up question is the BIM side, because actually, like, let's take Revit, for example. It may seem a bit annoying for you guys in a way that you guys kind of are able to go from design space Rhino to fabrication, and you still need to document, but you don't necessarily have to in a way, and BIM can be many different things. So do you find now like the documentation process in BIM is somewhat, do you see it potentially becoming redundant later on when you can maybe scale up printing to a house or something like that?
That's an interesting question. So we're exploring the idea of fabrication without any drawings at all, using
paperless construction.
HoloLens, augmented reality, mixed reality. And we've done, I think so far, the largest mixed reality fabrication project with the whale shark in Qatar for the World Cup, which was huge, and we did it in 2 months because we didn't have drawings, so we could just use our HoloLens. We had, I don't know, 4 or 5 of them, and a massive team, and we were bending off-the-shelf material based on what the HoloLens was sort of saying. So it's got a lot of potential, and that's using people, so to speak, not machine, which is actually really nice and empowering as well, because obviously we're training people by doing so. Robots scaling up massively, I think, yes, to some extent that it will always be modular, I think. Like, I cannot imagine a machine that's large enough to print a skyscraper. Maybe I don't know, maybe my imagination stops there. But I think we will always prefabricate modules. And these could be done, of course, with robotic tools, but there will always be a dose of assembly. I mean, any building is an assembly of stuff, really. It's very hard to imagine a single machine solving everything all at once, the universal, because So I think the notion of assembly will probably require mixed reality. The printing will probably be printing of modules. If you see our projects that push the envelope of printing from Conifera, was all modules repeated. And even if we were working on a timber project, we'd seek to have a module repeated. Symmetry of some sort. Galaxia was 20 rotationally symmetrical petals. I learned the hard way. The first projects we built at Burning Man were not symmetrical. Everything was different. Every single piece. I think when you're first do parametric design, you're excited because you think it's fine, digital fabrication, everything can be different. I can just do. Who cares about symmetry? Who cares? And then you're like, because for example, the writing, the engraving of the piece number, they didn't do it. They didn't turn on that layer. So we came to the desert without any
numbers.
And I'm like, if only there was some kind of logic to it. And then you realize that there's a lot of waste when you start laser cutting single pieces. So the notion of circularity and life cycle came in our studio very heavily because we don't have much choice really. So this came into the equation. Like, we didn't print in midair these bricks. One, because it's very slow and you don't have time. And two, if you print flat, you have the possibility of using your printer like a laser cutter, so to speak, but without the waste. So, and then you can ship modules that are stacked, so you're not shipping air. So really you have to think flat pack. And so, but where is the 3D printing if you print flat pack? So it's interesting when you start putting all this in the equation.
That's where the magic happens, isn't it? Because I think, like you were saying, you could script something and you can print it customizing, but sometimes it comes back down to, can you fit it in a container? Can you put it on the back of a truck? And at uni, you kind of, you're like, you hit this brick wall of a truck or something.
But it's true, at uni, do you ever, I think that's why we took our students to Burning Man, because how often at uni, in the comfort of our, sure, you might work all night, but the truth in the pudding, I love this expression, the truth is in the pudding, is because when you build something and you have to deal with the finance of it, you have to deal with the kind of sheer, what piece goes where, and how do I transport this from this to that, and where do I make it, and how much is it to make it there versus making it there, and what if I use off-the-shelf timber versus plywood, and what if, like the myriads of decision making that comes with reality of building is something that at uni is very hard unless you are pushed to do a pavilion or something of that scale.
Like a follow-up question, so bits we touched on there was obviously, I feel like you guys are becoming a true master builder in you design your own thing and you fabricate, you're building your own thing. I don't know if that's the intention, but do you see yourself being able to scale up this process? We already talked about printing components and things like that, but do you see a future where you could scale up this process to deliver, let's say, home scale or even above that?
I'm excited about the prospect of master building simply because I think cathedrals and temples are the most beautiful architecture there is by far. Like, you know, when you go in a cathedral, you're just, it's the, I don't know if you say this, apotheosis of design. It's when everyone came together, had a real empirical loop of trial and error, and built a common knowledge towards a higher purpose. Yeah. It's so beautiful, and it's to some much smaller scale what I've experienced when we built Galaxia. It was it was beyond one person. It was the communal effort of coming together and learning together. It was a learning journey. And so that's what I love about master building. And I think that when you separate, which is what society wants you to separate things. Of course, liability issues, you know, of course, you cannot know everything. Of course, you're going to have to compartmentalize and call yourself an expert in this field or that field. But, you know, I don't know, when you see the polymath of the Renaissance, like, they didn't put any limits in their kind of thirst for knowledge. And it's when you start crossing these boundaries that's why I said, like, although yes, this space is nice, I miss being next to the machines because it's that serendipitous moment of printing something that's for someone a failure, but for me something beautiful and a potential for something else. Like, and if you don't have that direct relationship, it's harder. It's harder to create this serendipitous creation. Sorry, that's part one of my answer.
No, that's great.
Part two on the scaling up is we're ultimately dependent on space. Like, at the moment we have a hangar that's relatively big, but we want it to be close to the city because we want to do we want to empower communities that are around us. We could have, and I'm sure maybe you'll see it tomorrow at AI Build, like if we were in an industrial estate, we'd probably have the capacity to have larger machines, scale up the operations. I really love decentralization. I love the notion of having, machines in containers and create hubs that can grow and ungrow. I love that notion. I think it's a lot more fluid than having a giant factory somewhere far. Because if you pursue that logic, I think for me, if we pursue the logic that ultimately we just need a huge factory somewhere where it's really cheap, you just end up with the same issues that we saw with, let's say, separating people from the making. And so therefore, I think we would not be truthful to our FabPub mission, which is to empower people with fabrication. I would much rather have small shops around the world and work as a hub than have a gigantic factory somewhere that produces huge things. Whether those small hubs can create something big together, I think this would be a very beautiful thing, rather than have one gigantic machine that somehow solves it all, because then that's not the collaborative stuff I like.
I like it, the transformers of maker containers that comes together to make the ultimate factory. It's also scalable, economical, rather than all these housing companies building factories. They build a factory and then go bust.
Here you go. It's investments grow, like cellular growth. And on Conifera, we didn't have time to print all the bricks, right? But who cares? Like, no one saw that. Galaxia was harder because it's a circle, so I can't just miss something. There is a lot of benefit to an aggregation-based architecture. Of course, you grow and grow. It's like nature.
Like with everyone that we're talking with, I've got to mention AI. And I know when we were doing our podcasts a few months ago now, you were with your students and they had walls of mid-journey stuff. How are you experimenting with AI now? And has AI found a home in your design process? And what are the tools you're playing around with?
Yeah, AI is now part of how we conceive things. I don't think we have a single sort of design presentation, or early design presentation, without a little bit of AI informing the choices that we make. We know that at some point, even if a client chooses the AI option, we'll have to make a 3D model out of it. So I think we just have to caveat a lot. AI is conceptual at the moment, and it's opening up possibilities. but it's, I think I heard that glorified Pinterest expression, maybe a little bit more than that, but it is very much an inspiration tool than a making tool at the moment. So it's I guess the early stages of Grasshopper where we all got excited. And then you hit the first wall, which is, okay, how we turn this into something I can actually use or make
or control it.
And so at the moment that's where the limit is. I'm not, it's probably going to open up, and we're actively trying to find ways to convert stuff. But it's very much at the moment an inspiration and a way to generate more stuff. Like I've got a collage here of drawings. Like I like to just completely let go of design sort of certainty. So even when it's a hand sketch, it's pretty much oh that's cool. Okay, okay. Yeah. Like letting yourself be surprised even by your hand.
Yeah.
And my hand is supposed to be my brain, right? So how can that work? Well, it's the same with AI, right? Like we're making decision. Design is nothing more but decisions along the way. If someone wants a green wall versus a blue wall, they are designing.
Yeah.
They don't have to be the painters. They don't have to have invented the paint. They are, and so whether I say grow this image or upscale this or upscale that, we're making design decisions along the way. So I don't know how different that is. It might be a little bit more fast. I think we're in a culture of fast. I mean, Tinder.
Just swiping AI images.
But hey, I met my wife through Tinder, and we have a baby now, so it's very real. It's a bit. I'm equally scared and excited about all these new potential. You look at TikTok and you're like, really? I just spent 2 hours looking at stupid videos, and I literally shifted when I could be reading a book that's continuous and create a thread. Is that bad? Is that good? We don't. No one knows. No one can claim to kind of know. To some extent, there is excitement. We can adapt to what's going on and see the potential in doing good.
Yeah, I think the speed thing is definitely a component. Like now we've gone from creating an idea that would, even if you're very quick, days or weeks, to now literally seconds or minutes. And I think that has its pros and cons.
Yeah.
I think, do you feel that AI is a tool, or has it crossed the line between a collaborator, would you say, or do you see them as one or the other?
I always saw Grasshopper as a collaborator. I always saw plywood as a collaborator. I always saw, my pen as a collaborator. When I was, 13 years old or something, we were taught this logo, which was a little turtle on Mac. Yeah. And you said, move one step, turn left. And then iterate this +1, right? Or something like that. And then you could see the turtle creates its path, right? So I think anyone who was very early days doing some early coding with tools like that realized that you could generate geometry based on a set of instructions, right?
I see.
And so is that turtle a collaborator because it looked like a turtle? Or can I do this with my hands just by being rigorous? Like many artists will have, you just set rules and then suddenly the music happens, right? Like many DJs now just set rules and then the rhythm happens. They don't have to play each one of the notes to claim authorship. Yeah. I come from France, so this notion of authorship is very important. But then I'm just like, but who's the author ultimately? Because what are we actually inventing? We're just big aggregators and decision makers and just generally excited antennas of humans. Like we're just connectors, right? And so I don't know. I as you can see from having two different companies, I'm comfortable with this notion of self-expression, and I feel like everyone has the right for this self-expression. But I'm equally comfortable with sharing knowledge because I feel like that's the only way you could have a true impact, and it just feels a lot more, let's say, useful to impact people positively rather than crush them down in saying you're an amazing architect with an amazing body of work and therefore forget about it,
Yeah.
Like I'm great. great. Okay, good, thanks. Like if you're a young student and you see a great architect, you're like, you might aspire to be that, but you might also be extremely intimidated.
Yeah.
Well, what if we broke that? What if it's accessible? What if you're part of it? Like, yeah.
Yeah, and that's what we're trying to do a little bit today, and I know what you guys do with your work. Oh, that's great.
Well, that's why I love these conversations, and that's why I'm always open to that, because I it's this notion. I think on the fast aspect of our generation, if I can just say this, because there is the Tinder and then there's the wedding, right? Yeah. There was a beautiful book by Daniel Kahneman that said thinking fast and slow.
Yeah, yeah.
And you think very differently when you think fast, and you achieve amazing things. You know, you obviously can build up massive knowledge intuitively and subconsciously, and then you have the slow knowledge, which is reading a full book. Yeah. Taking time to reread yourself, taking time to write and articulate a nice letter, taking time to do a proper piece of grasshopper rather than lots and lots and lots of stuff. So I do think that the gymnastic of switching from one to the other is important. Yeah. I think the risk is just to switch fully into a mad Tindering, right, without the wedding.
No, I think that's
to keep that analogy. Sorry, guys.
I think that's a perfect analogy. Actually, like I think I've been thinking the same thing. Is the speed in which the ideas, you can see maybe the thinking is quicker as well, and that's my only fear with the speed aspect is, are we losing the thinking? And even when I talk to a generation of architects before me, they have the same concern with Revit. For example, you just say, I want a section here, and you get a section, and you can clean it up. But they were kind of, you need to go through and think through those layers. And I don't think I've kind of grasped that until now, seeing the speed of AI. Yeah. But I think it's a really nice analogy though.
It's a real risk that people might think the tool just does it, and therefore I'll always seek for the tool, rather than know that the tool is here to help you, and that your slow thinking is what makes you special, rather than just a user of tools. Yeah. And we had that same problem. We generate the sections, and we didn't think that there wasn't a door.
Yeah, yeah.
And so it's like, well, could you not just print that thing and check if doors are everywhere? Could you make yourself a checklist? And that still requires making tools. I mean, checking that, it sounds obvious, but that every room has a door is an algorithm in itself. Yeah. It's a missing piece of algorithm, and it's your slow thinking that allows you to think, I still need to make a custom piece of, a plugin, let's say. And so the slow thinking is creating or identifying the missing points in our tools. Yeah. And it's in that crack that lies intelligence.
I really like that. Slow thinking is what makes you unique.
Yeah. It's the risk. I mean, people, new generation, don't even know how to spell much, and they don't. That's because they don't reread what they wrote, and that's because they don't take the time to actually think. Yeah. What you write is your algorithm, and it's your way of articulating your brain. I remember being the most annoying guy on the forums on Grasshopper, because I would ask tons of questions. Yeah. And I knew that if I formulated my question well, I might find my own answer. Right. And that process of creating a question was way more important than sort of the answer itself to some extent, because I trained myself to ask the right questions, which, Stack Overflow, those forums where they actually downvote you if your question is stupid. Yeah.
There's always on the Grasshopper forums, like, script's broken, please help fix.
Yeah. And then you're like, but what have you tried? What is your intention? Articulate yourself. You're a bloody human. Otherwise it's just like, I saw this image, I want to redo it. Why? Where is your soul? Who are you? Who am I? It's those are deep questions. These are the doubts, These are the crucial, it's okay to feel not okay. It's okay to feel like, who am I? Why am I depressed? Those are beautiful feelings, because that's when you find yourself. Yeah. We talk a lot about mental health. I think I went through a few depression. Okay, I'll open up. And those moments were quite crucial in understanding the value of things, or why I got in that state, and what mattered to me, or what mattered, or what were my core values, you know. And our office very much relies on key values that we write together and that we all share, because you'll see it's a very worldwide type office, and so you have to come together around key values, and that is an extremely important aspect of our studio. And these values, of course, are linked with what we discussed in design and tools and so on, but they're ultimately the core of it.
You can see it from the outside. Even, you know, you guys, you're not a new company, but you're not an old one either. But already you can see you've got very strong values. You guys are printing in bio-based materials. You invite people to come back and recycle the materials so you can print it again. I think that's one of the things that, again, makes you very unique. Last question is for young architects maybe in the audience that have ambitions to come work for Mamou-Mani or come make something in FabPub. What do you look for when you are hiring? Do they need to be experts in Grasshopper? What are the kind of qualities you look for?
So my most important aspect is, have you taken the time to understand like why you want to join us? You know, have you seen one of these conversations? Have you spent time slow thinking, writing something that's meaningful and shows that you inquired and that you went a little bit deeper than just saying, you know, mass email to everyone. I like people that choose, you know, I remember, I don't know, was it Xiao who sent me this incredible email. I think he's made a special sort of interacting element. It was just, it showed that he cared. I think if you show that you care and that it fits within what you want and we match somehow both ways, right? I think when you hire someone, they hire you too. And so
it is a bit like dating. You gotta make sure there's
exactly.
feeling.
Here we go again. So that's that. I mean, after that, of course, skills are important, but I'd much rather honesty. Like the number of times that people were telling me I'm an expert in this, and then the first technical question I ask, it just crumbles apart, and I'm just like, mate. Like,
that's the number one advice. Don't inflate your skill set on the CV.
No need. I'd much rather you're enthusiastic, you know, you've watched our lectures, you know what's going on, you understand the values, you understand what we stand for, and that you also understand why we created two companies and which company you want to apply for. Do you want to be a fabricator? Do you like hands-on carpentry, or do you like to sit at a desk? Like, you also have to be conscious of where do you fit within a structure, because there is a structure. You can't just be like, I want to join the whole thing because I like to do everything. And it's like, okay, but which bit of it? What's your piece of contribution to the thing? Like, I mean, I used to think you can be completely generalist. It's true. I used to think I could have an admin team that's also architects, but you can't, because there's your heart, right? Like, where do you naturally get drawn to? Are you more into do you struggle to, I don't know, spreadsheets? Do you love spreadsheets, right? It's okay, that's design, like, it's fine. Like, do you love to organize budgets? Are you an extremely people's-oriented person? Do you like to go out there with clients and party, right? That's fine. We need party people. Or are you quite kind of introvert and you'd much rather just spend your time resolving a really great piece of technical design? And that's fine too. Know yourself, right? And show that you know where your quality stands, and then it's even easier for me to know where it can fit. Yeah.
So apply today.
Hello, my name is Mathias. I'm the CTO of FabPub and Head of Design Systems at Mamau-Mani Architects.
All right, well, thanks for the tour. It's an amazing space, and to see all the crazy printers you have here. Maybe talk about your role at FabPub versus Mamou-Mani and how those two worlds kind of combine together.
Yes, absolutely. So I'm really interested in how to take drawings to the reality. For me, this is a very is a very connected process, and in a way I see myself a little bit as a link between the two companies. So I understand a lot about fabrication. I look a lot at the technology that we have here, and that sort of informs me about the sort of limits and constraints about the technology, and I try to feed that back to the design team, so that we can ideally in the design team draw things. We already have a pretty good idea how to make them. On the other hand, I also really like the freedom of the design team, just completely pushing ideas and pushing forms that are not necessarily yet constrained by the reality of a material or a particular process. So I think it's trying to keep a balance between those two, and connecting the two. And I think with Mamou-Mani, I think it's a lot about building more software tools to assist this process, so making the process more easy, and having a way also to sort of define these constraints in terms of a software, in terms of an application that the designers can use to make their job fun, and then and easy for the fabricators, because the designers already produce something that's quite close to something that we can make.
And you are literally running down that road from the designers to here and back.
Yes, I have a bit of a routine. I try to have a routine where I come here in my lunch break, and I spend the afternoon here, and I talk with a lot of the fabricators face to face. I think, yeah, it's I love working with materials. I spend a good chunk of my time just only looking at materials. I think it's basically, yeah, it's a big part of what we do, and both in terms of the architectural commissions and the products. So the materials is a big part of it, and this place is about being able to be hands-on with materials. A lot of the time when we design, we push materials to do what we want. But I think it's really helpful to understand how materials work, what they want to do, and also trying to find a way to maybe incorporate that into the design process. So I think that's something that actually initially really attracted me to computational design, the ability to include material properties in the software, so you have a drawing that behaves a little bit more like a material.
I think a little bit of a follow-up question to that is, you mentioned computational design. I think you have a background in computational design as well as the fabrication side. Obviously you can see how you're using computation on the design side, but how do you utilize computation in the fabrication side? You mentioned materials and things like that.
Yes, so I mean, computational design is a great tool to solve a lot of different problems. I originally got into it in order to generate what's called a technical design, a detailed design, actual specification. When we work with computational tools and create the kind of designs that also the Architecture Office is famous for, it often means a lot of different parts. So, you know, most of the time manufacturing is built around quantities of scale. You're trying to optimize something, you're trying to simplify something to a handful or even just one sort of piece, one component. 3D printing allows you to break this sort of constraint by being able to produce a different part with each print. But for this, we use computational, in order to feed this process, we use computational design not only to create very beautiful freeform designs, but then also to have a structured process to break these designs down quickly and efficiently to produce the specifications that we need. Often I work with mixed reality, augmented reality, then to look at these specifications. So they often never actually make it into a drawing, but into a sort of 2D specification drawing. But we need the 3D model in order to do the print or to do the to do a laser cut. So we try to, it's basically about sort of bridging this gap and having the right detail where we need it.
And you guys have developed your own plugin, Silkworm, right?
Yes.
Maybe explain what is Silkworm and what do people use it for?
But so when you go from the drawing to a physical object and you use different tools and technologies and machines in the process, there's a lot of steps where you're sort of translating from one domain into another. So a machine like a 3D printer, it's able to follow your drawing by being able to move through space freely. But this movement is achieved by a combination of a sort of mechanical frame and motors, and there's a software running this machine in order to recreate a certain movement, and this is the code that's running this movement is called machine code, and if you want to work with the machines completely freely, it's good to speak this code. It's good to speak this language. So if you don't, it's a little bit like being able to speak a different language or using some kind of auto-translate function to do that work. The auto-translate will probably get you there, but if you're really, if there's something that's very particular, or if you're trying to push the technology to its limits, it's really, really helpful if you can sort of speak this language. And Silkworm was developed in order to do exactly that. So you can, you're not relying on what's called a 3D printing slicer, which is a common software that you put in your shape and it's kind of creates these layers and then writes machine code for your printer to do it. We basically program a software in Grasshopper to write the machine code directly, and that's then running that's then running on the printer. So it basically by not using a commercial slicer, which is sort of this bit of a black box, we are able to have a sort of more direct input on how things work. Yeah. And on the robot, this is even more interesting because the robot is even more capable. So the industrial robots are have been developed for a long time and have by quite big companies who have invested a lot of time into making this work. And because of the extra movement and because of how you can ask the robot to sort of move from one position to another position, there's a whole another world of possibilities that we're looking into at the moment. It's quite interesting for us because in the design, on the design side of things, we really like to work with very continuous curves and very continuous surfaces. But for example, on most of the 3D printers require a mesh representation in order to work, which means that we need to take these beautiful continuous surfaces and break them down into flat triangular faces. And then we need to ask the robot or the 3D printer to smooth all these faces out to go back to our beautiful forms. And what we can do with the robot, we can basically we can ask the robot to move following the same kind of NURBS and curves that we use in the drawing. So we don't need to do this step anymore. So it saves us a step in the process, but it also it more accurately recreates the shapes that we are drawing in the first place.
You also mentioned a little bit that you have augmented reality that you use to aid in this process. How does it work with 3D printing? You like overlaying, to make sure the printer's going in the right direction, or assembling pieces? How are you using augmented reality?
Yes, so for me, augmented reality, mixed reality is really powerful because it helps with every step of our process. We can use it to look at an initial design. We can use that to show it to the client. We can use it on site to look at it at scale 1 in the location, but then we can also use it to fabricate from. We can look at a hologram and directly fabricate from. On the robot, we use it to do quality control. You can imagine if you're printing this complex freeform shape, it's quite difficult to know actually whether the robot did what you ask it to do. So you can basically overlay the hologram onto the robot bed and you can see what the discrepancies are. So it's a really powerful tool, and we're basically sort of in the process of integrating it as a workflow at all of these steps. So we are using it to show the work to clients. It's always really amazing for clients when, you know, we're working on this restaurant at the moment, and you know, it's just a construction site, and you can take the client there and we can look at the interior at scale 1 in location. And funnily, it also becomes for us really powerful, because it's not a presentation, it suddenly becomes a design session, because you suddenly realize, oh, these two things are close to each other. Okay, I need to lift this up a bit, I might bump my head. So it's a lot of very intuitive things that unfortunately you often find out when it's a little bit too late. You installed it and then you bump your head and go like, oh, that's a shame. So so we are at the stage of trying to incorporate it more of a process, so that all the members of the team can also use it in their work. And sometimes I think it's a nice combination with the 3D printing, because for me 3D printing is more sort of slow and expensive, and mixed reality is fast and cheap. So if you have, it sort of opens up the spectrum where you can sort of go like, okay, this much 3D printing, this much mixed reality, you can sort of combine things and find a nice way through it.
Is there a particular software that you use for that, like Hologram, for example, or, you know, headset hologram versus just an iPad? Do you find one is more successful than the other?
We use the Microsoft HoloLens with Hologram, and we work very closely with them. We're sort of alpha testers, and we have regular conversations about ideas, about features, things that work, that we would like to see. The Hologram also works with tablets or phones. And I think it's really powerful also to use it like that, and it's kind of cheap because most of us already have a phone probably, and the phones phones are perfect augmented mixed reality devices because they're already so integrated. You have a screen, you have a camera, you have motion sensing, you have sort of this combination of technologies which is quite advanced and rare to have all in one place. So the phones are great. The headsets just give you this one extra dimension where you can actually see in stereoscopic 3D vision. So it's the one thing that I'm always surprised about when I think about how much design is done on screens, that you spend all your time sort of rotating your view to get a sort of a sense of what you're doing, but you cannot really see it. And the headset is just an easy way to just go, okay, let's have a look at this. What do I really want this? Is this detail working? So I think it's pretty exciting, and it's also it's funny because it's quite new technology. So there's a lot of it's a bit of a blank slate. You can do some small experiments and still have quite a sort of big impact in the process. I guess like many of us in this field, we are looking at what's happening with AI, with artificial intelligence, with generative design. I think I think in terms of going sort of text to 3D, we're still sort of at the early stages, but there's already some nice possibilities with doing 3D representations just from from images that you've generated. I think AI technically should be very powerful to do 3D printing, because I think AI is good when you set it clear constraints. If you have very clear instructions, I think it's a really amazing tool to explore these possibilities quickly. We are talking to a big French. We've started to work with Dassault Systems, who produce CATIA and XGen and SolidWorks, in exploring that space a little bit together. So it's really nice to have a big software partner like that to try to sort of scratch the surface.
Yeah, I think that would be really interesting to see how AI will affect 3D printing and the making process. I think that's going to be an exciting future.
Yes, it's at the moment, I think for me, I'm looking at mainly on the design side, because it is early stages, and I think there is you can imagine as as a fabricator, we need very precise detail. It needs to everything needs to be fully three-dimensional, very nice, clean detail. So you can fabricate, you can create the specification from. So I think AI is not quite there at the moment, but so it's probably more interesting to speed up the conceptual process. So this is definitely ongoing. But yeah, it's always exciting to think about how these things can be applied.
Yeah. All right, guys, thank you for joining us on our ArchiTech tour. An amazing tour of both Mamou-Mani and FabPub. I really think this is going to be the future of designing and making. If you like this episode, please give us a like and a subscribe to help us grow the channel. Otherwise, I'll see you in the next episode.